Hi, my name is Lorenzo, and I would like to talk about my research on epidemic in socially structured populations. And the idea is to compare different models to understand when we can get away using a simpler model. And so assume for a moment we are in a pandemic context or during an outbreak of a new infection, and we have very little information. For example, we have the incidence curve, so an exponential growth in the incidence, and there have been many models that have been developed in the literature for epidemics in a population with a social structure. So we can have models with households, models with age stratification, or network models, or models of various type. So the idea is that all these models could fit equally well the early growth, but they might lead to different predictions. So the question of which model to use for an outbreak is actually a relevant question. And the problem is that comparing different models is quite difficult, and they may fit the early growth equally well and lead to different predictions. So the choice of the model is usually determined by data availability or policy objectives, which is totally fine, but sometimes even by more arbitrary criteria. For example, what the researcher is more accustomed with. So this is an attempt to provide a more scientific criteria for choosing between different models. So the idea is that I start with the model which I consider the most complex model I am working with, which has two age classes, adults and children, and a household stratification. And then from this model, I explore the parameter space of this model, and then I map this model into structurally simpler ones, one with only age, one with only households, or a completely unstructured model. And then, assuming that this most complex model is the truth, then I predict from this model the final size, the peak incidence, and the time to the peak. And then I use the simpler models to predict again the final size, the peak incidence, and the time to the peak, and see how wrong I get my predictions. And so by doing that, I can plot some graphs like this one, for example, focusing from the moment of final size. On the x-axis I have the amount of within household transmission, and on the y-axis I have the relative susceptibility of children versus adults. And for example, in the blue region of the parameter space, where there is not much transmission in households and not much difference between adults and children, then all models, like the most complex one, the household only, the age only, and the unstructured model, all predict roughly the same final size. So essentially we can get away with an unstructured model. We can forget about all the complexities of the social structure and still predict quite accurately the final size. In this region here, we need to include households to get accurate predictions. In this region here, we need age. And in the red region, where there is a lot of transmission within household and a lot of difference between adults and children, then we need both types of social structure. So then I do the same for daily peak incidence, time to the peak, and then I put the information together, trying to reject the simple model when at least one of the three outputs is still wrong. And in this final graph, I try to explore better the parameter space, and the final outcome we can observe is that in general, adding the household structure is not particularly relevant for getting an accurate prediction and makes the model much more complex, while the age stratification seems to be much more relevant for accurate predictions of these three outputs, like peak incidence, time to the peak, and final size. So in general, for many infections, like here is a region of the parameter space where I could place the past pandemic, this would suggest that early on during the pandemic, we could have already said with a study like this that you don't need to use household models to get accurate predictions, but you need to include an age stratification. And for other infections, it seems to be more or less the same result.